This section is looking at section 12.2, which is the surface area of prisms and cylinders. If we start off first defining a prism, it is a polyhedron with two congruent faces called bases that lie in parallel planes. If you look at the shape off to the right, that is a hexagonal prism, and in that hexagonal prism, the bases are the hexagons, so that's the top and the bottom. We can think of them as the floor and the ceiling, if this were to be a room within that hexagonal prism. The lateral faces are the parallelograms formed by connecting the corresponding vertices of the bases. Now, if this was a room we were looking at, these lateral faces we could think of as the walls within the room. Then those segments connecting the vertices they call the lateral edges will be where the walls meet. The surface area is going to be the sum of all the area of the faces. So that's going to be the walls, the ceiling, and the floors all combined. The lateral area is going to be a specific part of the surface area, and that's the sum of the areas of the lateral faces, which will just be the walls. So surface area is the whole thing, lateral area is just the walls. If we look at an example where we just look at that lateral area, we have a pentagonal prism where I have each side length is 12 and the height of the whole prism is 6. One way to look at this is to say, well, each rectangle that makes up a wall is 12 by 6. And so the area of that rectangle is 72. We have 5 of those rectangles. Therefore, we could do 5 times 72, and we get 360 feet squared. And that would be perfectly fine in finding those areas of those walls, but for what we're going to do with surface area, let's look at it a little bit different way. If I was to cut this prism and open it up so all the sides were next to each other, I would have a long rectangle that it could be broken up into 5 pieces. And each of those pieces would have a base of 12. And the whole thing has a height of 6. If I were to combine all of these 12s, I get 60, which is also the perimeter of this prism. So now instead of multiplying 5 times this area, I took 5 times 12 and got this 60, which is still going to be multiplied by 6, which still gets me a total of 360. But what this lets me do is say that the lateral area is the perimeter of the base times the height. And for where we're going with surface area, looking at the area of all the surfaces of the prism, this is going to be an important part because this covers all of the walls. If you think what's left, well, the bottom and the top, if we can find those areas, which would happen to be the same, we would have the entire surface area. So, like we said, we need the 2 areas of the base, that's the bottom and top, the floor and ceiling, plus the perimeter of the base times the height, which was our lateral area. So this is the formula we shall use for a prism. S equals 2b plus p times h is the short form. So if we look at our first example, a rectangular prism, I can shade in this base here. And why the base is important is if you look at the 3 things we need, area of the base, perimeter of the base, and the height, 2 of those 3 things actually come from the base. So it's good to get into the habit of drawing the base off to the side, the way we would look down on it and make it a rectangle. Because then we can look at that base and really get the information we need out of it. So the base area is going to be 5 times 6, or 30. The perimeter of the base is 6 plus 5 plus 6 plus 5. We're just adding all the sides together, which is 22. So that gives me 2 of my values. All I have left is the height. Now the height is actually the distance between the bases, how tall the prism is. The height will not be a value within the base. It separates them. In this case, it's also the value we haven't used yet, so that is our height. So surface area is 2 times 30 plus 22 times 4. That gives us 60 plus 88, or 148 feet squared as our surface area. Now, if we look at another example here. Here we have a triangular prism. In this triangular prism, our bases are these triangles. Now, although it's not looking like the floor and the ceiling like that other example, we still have to recognize that those are the bases. The bases need to be congruent to each other. They need to be on parallel planes, and these triangles are going to be the bases. So if I draw the base off to the side, I have 6 and 8. First thing I need is the base area. Since it's a triangle, it's 1/2 6 times 8, which gives us 1/2 of 48, or 24 inches squared. And then the perimeter should be 6 plus 8 plus this hypotenuse. Now they didn't give it to us directly, but we can see over here if that's 10, this will also be 10. So in fact we have a 10 there, we can't find the perimeter. But if they didn't give you that value, you could always use Pythagorean theorem to find what that value would be. So then you can ultimately add all the values together and find your perimeter, which is 24 inches. Last thing we need is the height. Now the height of the prism is the distance between the bases. So it's really tempting to look at the 6 because it represents a height, but that height of the prism is that distance between. It needs to be 13, also the value we haven't used yet. So we write our formula out, plug in our values. We get 2 times 24 is 48. 24 times 13 is 312, and that gives us 360 inches squared. Next we have a rectangular prism. Now we have options in a rectangular prism which one are the bases. If we chose the bottom and the top, that'd be probably the most common choice for the bases. But to do something different, let's say that these are the bases we choose. Kind of like that triangular prism we just looked at. If I do that and I draw my bases, my base area is 3 times 2, or 6. My perimeter of my base, 3 plus 2 plus 3 plus 2 is 10. And then the height is that distance between the bases would be 8. So my surface area is 2 times base area plus perimeter times height. 2 times 6 plus 10 times 8 gives me 12 plus 80, which is 92 feet squared. So that's looking at prisms, and how the prisms may vary is depending on what the base is we have. We looked at a rectangle, we looked at a triangle, we may have hexagons, we may have pentagons, and it really comes down to finding that base area, finding the perimeter of the base, and then plugging them in. But if we shift gears now and look at cylinders, a cylinder is kind of the circular version of a prism. In this case, though, our bases aren't polygons, but they are circles. So the top and the bottom are now circles. If we open it up and look at it as a net, we have the top and the bottom, where we can find the area of the base, and we have what was the lateral walls, or all the walls going around it prior in the prism, is now just one big rectangle. And if we were to open up within a cylinder, we do get a rectangle there. Now, the area of the base is pi r squared for a circle, so we can do that for both of those. But then the lateral area is actually the circumference, which is this value, times the height. So we can use that to help us find our values. Now this comes together with the same idea that we had for the prism to give us the surface area of a cylinder, which is 2 times the area of the base plus the circumference of the base times the height. But in this case, since it's a circle, we always know what the area of the base, which is the circle, is. It's pi r squared. Same thing with the circumference of the circle or the base, which is 2 pi r. So we can take those and actually just plug them into our formula to get this form. And this is nice because it gives us a general form we can easily go to. If we look back at what we did with the prism, it depended on what the base was. We had to find the base area and the perimeter. But that would be vastly different if it was a rectangle, a triangle, a pentagon, a hexagon, even if it was the different types of quadrilaterals we looked at. If they're different, we still have to go through a different process. But for a cylinder, if we can identify the radius, we can identify the height, we can just plug them in, and get 2 pi times 3 squared, it's the radius, 2 pi times 3 times 4, that's the radius times the height. 3 squared is 9, times 2 is 18 pi. 3 times 4 is 12, times 2 is 24. We have 24 pi. That leaves us with 42 pi for surface area, and that's feet squared. Then if we look at our next one, it's going to be 2 pi times 2 squared plus 2 pi times 2 times 9. 2 squared times 2 is 8. 2 times 9 is 18, or is 18, times 2 is 36, and we get 44 pi feet squared. Now, last thing we have to look at is what if we're not given all the dimensions and have to find the surface area, but we actually are given the surface area and we need to find a missing value. So we're still going to use the same formula, 2 times the base area plus perimeter times the height for this prism, but now we're actually looking for this dimension. Now, it may be tempting at first to look at this bottom base here, the 4 by x. I'm not going to use that one. Now, we could plug it in. As long as we use it correctly, it would work out to an answer, but we could make it a little bit easier. Because the problem is, if I use this bottom piece here, my area would be 4 times x, which should go here. My perimeter would be 4 plus x plus 4 plus x, which would ultimately be 2x plus 8, which actually gives me x's in a couple places. It could add a little bit of a couple more steps to solving. By all means, not impossible, not even that difficult, but we can make it a little bit easier. And this also gets us used to realizing in a prism we have options to the bases that we choose. A rectangular prism, I should add. So I'm going to use those as my bases, because if I do that, x is now my height. My base is 4 by 4, so base area is 4 squared, or 16. My perimeter, 4 plus 4 plus 4 plus 4, is also 16. So now when I go to solve, I have 192 equals 2 times 16 plus 16 times x. Gives me 192 equals 32 plus 16x, which is 160 equals 16x, or x is 10 inches. Now when we look at a cylinder, we look at our formula. 2 pi r squared, 2 times the area of the base, plus the circumference, 2 pi r, times height. This is s. We're going to plug that in. That's 12, but that's our diameter, so our radius is 6, and our height is x. Now when I plug in what I know, I have this, which simplifies to be here. Now, since I did not get my original surface area in terms of pi, it's just a whole number, I'm likely going to have a decimal here. So we'll get an answer that's a decimal. If I were to multiply this by pi as a decimal, I could subtract it from 754 and then divide by this value, because really we just want to get x by itself. But I could go a little bit different route. I'm going to divide everything by pi. And in doing that, 754 divided by pi is about 240.005. For the sake of this problem, we're going to say it's about 240. We'll write the approximate symbol there. 72 pi over pi becomes 72. 12 pi x over x becomes, or 12 pi x over pi becomes 12x. So we are approximating, but we can do this. We now subtract. I get 168 is approximately 12x, and x comes out to be approximately 14